the question is why do we need a common denominator? Because remember when we had when we talked about addition and subtraction, it being a counting process, we had to count things which were alike. So that if we go back to the idea of arithmetic, and we just take a look at this side here, and I notice that I'm going to try to count 1/2 and 1/4. Well, if I were just look at the denominator, it's not the same, so I'm not counting like things. However, if I were to say be able to put things in fourths, because 1/2 can be put in fourths. If I take a look at it, these boxes are in fourths, and here is 1/4, and here is 1/4, and 1/4 and 1/4 together gives me 1/2. So essentially 1/2 can be written as fourths, namely 2/4, and then I have 1/4. So now I've got an issue where I'm counting how many fourths I have, and you notice since they are all the same thing, I can count how many I have. I have 1, 2, 3 of them, and that's what you see here. Because these are all in fourths, this guy ends up being 3/4. So essentially this is 2/4 added to 1/4 gives me 3/4, and that's essentially I have to make sure I'm counting the same size pieces. Okay. Now what happens, in the error that I see most often is this one, where somebody will come in and say, okay, 1/2 plus 1/4, add the numerator, add the denominator. So obviously 1/2 plus 1/4 is 2/6. Well, let's see if that's the case. Here's 1/2 as a size representation. Here's 1/4 as a size representation. If I were to put these two things together, I'd end up with something that looks like that. Now if I look at the size representation of 2/6, that is in no way, shape, or form the same size as this thing up above. No way. They're not equal. You don't get the same shape out of it. So that says you cannot add the numerator, you cannot add the denominator. It's a counting process. So the next question ends up being, how in the world do I find the common denominator so I can add these things? And that's what our focus is going to be. In arithmetic, you don't have to care. You can multiply the denominators together, and that becomes the thing that you're going to be your name of the fraction. Then you come down with this ugly looking fraction that you can reduce down because they're all numbers. In algebra, it would be enough to slit your throat. It would be, oh God, no, not that, anything but that. Okay. But we would find that if I found a number that both 2 and 4 divide evenly, it would be 4. So that's why 4 became the denominator. 8 would be, in arithmetic, an okay denominator. But in algebra, the smallest one would be 4. So if I were looking for something that would be between 2 and 4, something that we call the least, the smallest common denominator, I would look for a number that both 2 and 4 divide. I'd start out with 2, and I'd break 2 down. And 2 would be 2, and then 2 times 1. And then I would look at 4, and it's 2 times 2. Now, I could multiply 2 and 4 together to give 8, but we said that's too big. That's bigger than what we actually would need. What would the smallest be? We call it the LCD, or least common denominator, and I build it. I want a number that both 2 and 4 divide evenly. So I want 2 and 4 to divide, not dive, but divide, D-I-V-I-D-E, evenly. 2 and 4 to divide evenly. In order for 2 divided, it must have a 2 in it. So does 2 divide 2? The answer is yes, so it divides that number. Now, I want 4 to divide it. If 4 is going to divide it, it needs to have 2 2's. You notice it already has 1 2. What it needs is a second 2. Now, does 4 divide this guy? Yeah, you have a 2 and a 2, a 2 and a 2. What I've done is I've gotten rid of any overlap that there might be. So what is the LCD? The LCD is 4. And that's how you go about finding it, the smallest number. Arithmetic, it's easy. Algebra, you try that, you'll be sorry. How sorry? Real sorry.